Hello, good morning, everyone. Dear authors and invited guests, welcome to Technical Session 5C. I am Karthik Bharadwaj, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 9th International Congress on Information Communication and Technology, ICICT 2024, London, UK. The 9th edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th February 2024, and the virtual event is being held through Zoom, that is 21st and 22nd February 2024. I hope you will enjoy the knowledgeable session throughout the day. In this session, we have 6 presentations, and each presenter will be given a time of 12 minutes. At 10 minutes, I will read a gentle reminder, and there are 2 minutes for question and answer round. There is another request to all the participants to stay connected with us till the last. If you have any query or update, you can write it to me in the chat box. Now, let me introduce you with today's session chair, Professor Amar Bukit. He's an associate professor at Vishwakarma Institute of Technology, Pune, India. He has 18 plus years of teaching experience. His scholarly contributions are impactful with 70 plus international conferences and journals. Sir, kindly acknowledge our participants.
Okay, thank you for the introduction.
Thank you, sir. Now we are moving towards the first presentation of the day. For the first presentation, I would like to call Ming Wang for the paper title ALU Meta Module Based Design Methodology for Microprocessor Architecture Tools. Sir, you can proceed with the presentation.
Thank you. I'm going to share my screen.
Sir, now you can share a screen.
Okay, thank you. I'm sorry, can you see the screen now?
Yes, sir, your screen is visible to us.
Okay. So can I start out? All right. I'm Wang Min from Meiji University. The theme of my presentation is ALU metamodule-based design methodology for microprocessor architecture tools. Let me begin with a table of the contents. First, I will introduce the background and overview of this research. And next, I will explain how the ALU module is decomposed into 3 steps in this research. Then I will introduce the functions of the ALU metamodule based on the 3 steps. The ALU metamodule configured with a metamodule will be simulated, and the verification results will be shown using a demo. Finally, the conclusion of this research will be presented. Start with the background of this research. We have been researching and developing MIMAT, a tool for designing microprocessor instructions. MIMAT can simulate and design instructions for different types of microprocessors. However, once the specification of the processor is changed, the MIMAT simulator requires to redesign the hardware modules inside the simulator. So this research proposed a new module design method, which is called metamodule-based design methodology, to solve this problem. Let me introduce the overview of the metamodule-based design methodology. In this research, we chose to use this design method to design ALU module with multiple arithmetic and logical functions. First, to implement this design method, we have investigated the instructions of ordinary MPUs, which are ARM commit MIPS RISC-V. And in this research, the functions and the data-wise were extract from the summarized instructions, and the metamodule are designed with the generalized functions. Next, let me introduce the mechanism that breaks down the ALU execution flow into 3 steps in this research. In the investigation of the function of the instructions, we compiled a set of instructions for numerical and logical operations. As a result of the research, I found that complex instructions can be realized by combining multiple simple functions. Therefore, I decompose these instructions into pre-processing, main function execution, and post-processing of the results, and categorize of the necessary function by categorized the necessary function by step. The three step is named as ALU pre, ALU core, and ALU post. To illustrate the three-step mechanism, I will use ARM QS16 instruction as an example. This instruction splits two 32-bit input data into 4 hardware data and performs two side addition using the divided data. Then performs a sign saturation to the result and the addition of the addition, and finally gets 32-bit output data. Normally, this instruction has no step division, and it is realized with a dedicated circuit. So in the case of three-step execution flow, it can be realized with only simple functions by dividing in the ALU pre-step and adding in the ALU post-step and saturating in the ALU post-step. So this study divides the ALU instructions of the 4-type CPU, which are commit, ARM, MIPS, and RISC-V. And it divides these instructions into 3 steps. We then summarize the functions required for each step into a new formula. Here is the generalized function of ALU 3-step. The ALU pre-step provides division, exchange, sign, and zero extension function for input data. The ALU core step provides arithmetic and logical operations and absolute value of the input data. The ALU post step provides saturation, sign, and zero extension, and status processing functions to reflect post operation flags in the status. Additional functions can be defined as custom functions if there are other special instructions. After defining the 3 steps, we designed ALU metamodules based on them. There are 3 types of ALU metamodules, which are named as ALU pre-0, ALU core-0, and ALU post-0. These metamodules are virtual modules, which could be instanted by given parameters such as bit length and specific range, or etc. ALU can be composed by using the instant modules. First, let's look at ALU pre-0. ALU pre-0 metamodule has a select, sign, extension, and zero extension functions. Select is a function that outputs a specific range of data from input data and is used to divide or exchange data. Sign extension and zero extension are sign and zero extension processing functions for the input data. Next, let's look at the ALU core-0 the metamodule. The ALU core-0 metamodule has functions for arithmetic and logical operations. Among these, the arithmetic operations add and sub will handle the signed and unsigned cases separately, and flags that occur are also recorded separately. In addition to the arithmetic and logic operations, ALU core-0 also has an ABS absolute function in consideration of ARM's absolute value operations. Then about the ALU post-0. The ALU post-0 metamodule has set, sign extend, zero extend, and status functions. Set is a function that performs saturation operations on the input data. There is also processing for signed and unsigned cases and for the Q flag. Sign extend and zero extend, which are the same as ALU pre-0, perform sign zero extension on the calculated data. The status function is used to generate the appropriate status for the flags generated by the other operations. Here we reconsidered the QS16 execution flow with metamodules. In the ALU pre-step, 4 modules are instanted. Each of them divides the input data into half-words using the select function. The ALU core step inputs half-word data to the two modules and outputs the sign addition result and its flags. In the ALU post zero, in the ALU post step, two modules perform the saturation operations and receive the flag in the other module and process the status. In this way, the ALU instruction can be realized using multiple submodules instanded from the ALU metamodule. In this research, ALUs for MIPS and RISC-V MPU were built with submodules instanted from the ALU metamodule. So the most complex case for the ALU, ARM ALU can be built with 13 submodules from ALU pre-0, 7 submodules from ALU core 0, and 8 from ALU post 0. So in this way, it is confirmed that our metamodule-based design is able to design various ALUs efficiently. Now we will verify the ARM ALU composed by submodules with a simulation program. The window you see now is the MyMat diagram tool. The circuit is displayed on the bottom, and the stage information is displayed on the top. First, we will input the program. The prepared program loads data into GL1 and GL2 and executes QS16 instruction. The calculation results and flags are stored in the data cache and to the status register. After the execution, the circuit and the module blocks can be viewed, and the details information for the module is displayed in the module viewer. So here the circuit of the instruction, which is QS16, is shown in the video. Now we will use the module viewer to view the information in the ARM ALU. In the ARM ALU, there are buttons to display submodules except for input data calculation and output data information. So by clicking each button, it will pop up the viewer of the corresponding submodules. The information corresponding to the previous figure is shown in this demo. So here, by clicking the pre-zero button, the ALU pre-zero submodules will pop up as shown. So the same case for the ALU core 0, it will show the detailed information which contains the
Sorry to
input
interrupt,
data and
sir,
output
but you
data.
have 2 minutes to conclude.
Oh, okay, thank you. And here it shows the two modules for the created by the ALU core 0. So next button for ALU post 0 will shows the status will show a submodule with state function, which contains contains flags from other submodules, and the status and the set function with other two more submodules from ALU post 0. Here's the information of the ALU post 016B, and next one will be the ALU post 016A. So after confirm the information of the ARM ALU, we will confirm the simulation result, which is loaded into the data cache and the status register. So here the sum data of the simulation program is stored here, which is 0x7FFFF and has 8000. The correct answer is shown in here. Next one, the other result is the Q flag, which is true shown in the status register module view. Finally, the conclusion of the research, we have proposed a metamodule-based design methodology, and we have demonstrated that our metamodule-based design methodology is very valid by focusing on designing different various ALU modules. And that's all about the presentation. Thank you for your listening.
Okay. So it's a nice presentation. So I'd like to ask the question, have you compared your work with the existing work?
Sorry, can you ask your question again?
Uh, are you comparing your work with the existing work?
Existing work. Do you mean other
Yes.
other tools for the MPU?
Yes, yes, yes.
Actually, we are on the process which developing this tool. So we haven't compare with other tools. I'm sorry.
Okay, okay. So what are the performance analysis particular instructions? How many instructions you have taken for execution?
Instructions for the demo video here have executed the 4 instructions, and we have tested all of the ARM instructions, and well commit ARM MIPS and RISC-V integer calculation integer instructions. So I haven't counted for the instruction, but it over 50 instructions have been tested.
So are you comparing normally how much time it is requiring for execution, right? And how much time it is required by your module?
Well, the time of the execution, actually we haven't recorded the time in the during the simulation, but here here the demo can show this tool can actually can shows the simulation time. I think it's here. Sorry. So the time here can be recorded here. So so during the
Okay.
experiment, we haven't recorded the time. I'm sorry.
So please compare with the
So shall we move forward?
Sorry, I cannot hear the voice. Am I offline?
yes, we can go ahead with the next presentation. Thank
Okay,
you.
sir.
Thank you.
So before moving forward, I would like to introduce you with today's next session chair, Professor Emmanuel Samuel Metsuini. He is a senior lecturer at University of South Africa. Sir, kindly acknowledge our participants. I think so, sir is facing some network issue. It's okay. Let's move forward to the next presentation. For the next presentation, I would like to call Mr. Peter for the paper title Development of an Automated Feeder for Free Grazing Meat Producing Animals. Sir, you can proceed with your presentation.
Hello, can you hear me?
Yes, yes. Please go ahead.
Okay, thank you very much. I will present
Yes.
the paper called Development of Automated Feeder for Free Grazing Meat Producing Animals. So the automatic cattle feeder is a system that automatically provides feed to animals on farms. It is designed to facilitate and optimize the animal feeding
Sir, your screen is not visible to us.
I beg your pardon?
No, sir, your screen is not visible.
Presentation is not viewing.
Can you hear me, or would you like to start the video or what?
The screen sharing. We are talking about the presentation.
I'm sorry about
Slides.
that. Okay, sorry about this.
Yes, sir, now it is visible.
Okay, so I'm starting with the presentation. So as I said, the paper is development of automated feeder for free grazing meat producing animals. And the automatic cattle feeder is a system that automatically provides feed to animals on the farms. It is designed to facilitate and optimize the animal feeding process without the need for manual management or supervision by the farmer, reducing the need for manual laborers feeding. It is characteristic of automated feeders that the animals themselves participate in the feeding process. During the autumn and the winter season, the pastures don't have enough amount of food as the animal need. They need to, when they need it, they approach the automated feeder and feed. This is achieved by through the wearable embedded RFID sensors, which is a radio frequency notification that recognize animals individually and control access to the food. The sensors could be formed as capsules in the stomach of the animals. They could be put as bracelets on the legs, or they could be put on the neck of the animal. The reader on the other side is located in the feeder. One of the main advantages of this, of this automated feeder is that animals receive food on schedule and according to their nutrition plan, without the physical presence of the farmer. The automatic feeding mechanism can be programmed to feed the exact amount of food to each animal according to its needs. Another advantage of this automatic feeder is that the reduction of food loss because it enables to control and accurate dosing of nutrients. The automatic feeding mechanism can help to feed the animals regularly to ensure the optimal digestion. Depending on the ambient temperature, the feeder can offer different type of food, such as hay, fodder, grain, or other nutritional supplements. The improper or unbalanced feeding of the beef cattle is associated with energy and protein deficiency, which limits growth, body development in heifers and young bulls, productivity and reproduction as well. The digestibility of protein of different types of forages varies greatly, and depending on the whether they are grains, legumes, hay, or and so on. The body conditions of the cows in the late autumn and early winter is related to the total quantity of quality of the fodder required on the farm. Cows in emaciated states, especially in the autumn, must gain weight throughout the winter to deliver a live, healthy calf, provide sufficient milk, become pregnant, and calve the following year. Nutritional requirements are different, and in this situation, testing the forage and providing a balanced ratio to meet the needs of each group becomes more important. The device of automatic feeder for free grazing animals is shown on the figure below. It consists of 4 hoppers in which there is a different type of food. This is number 1 in the figure. These bunkers are united by a transport system, which is number 2, in a common main unit, number 3. This block contains sensors, microcontrollers, a scale, and RFID reader. The role of the thermal sensor is to measure the temperature of the environment, and depending on the measured temperature, the microcontroller of the system located in the main unit sends a signal to one of the 4 hoppers. When a certain hopper is signaled, it automatically opens, pours a certain amount of food into the feeder, and then closes. In the lower part of the common block is located the feeder itself, which is number 4. On the bottom is installed a scale for accurate dosing of food for each animal. The technology RFID, or radio frequency identification reader transponder, was used to identify the animal, and the communication resembles some wireless technology such as radio transmitters, Bluetooth technology, XB LoRa, and so on. The connection between the microchip and the antenna on the device is known as RFID tag. The antenna transmits the stored data to the reader and converts the radio waves into the digital information. To process this information successfully, the tag must be within a range of the reader. The tags have a small amount of memory that stores a unique tag identifier called TID. It cannot be edited, and depending on the tag design, the stored data on the tags can be used in 2 scenarios, read only or write only. There are 2 options, passive and active tags, which are available on the market. The passive tags are shown on figure 2. They can use the energy from the reader's electromagnetic field and have a relatively short range. They are very thin, can be placed between layers of papers and or in a mini capsule, and they're extremely cheap. That's why they are commonly and what's used compared to the other one. The principle of operation of the automatic feeder for free grazing animals consists of the following components. Data reader, which is located in the main block, and when the animal approaches the feeder at a distance of less than 1 meter, the chip, which is mounted on the animal, sends a signal to the reader. It identify the animal's process and then process the signal. It passes to the microcontroller, and based on the information about the animal and the ambient temperature, the corresponding hopper delivers a certain type and quantity of food according to the needs of the animal which is approaching. The following main components are part of this system. They're RFID module, a temperature sensor, microcontroller, and weight scale. And of course, the reader model with antenna, which is the most important thing of the whole system. For proper functioning, each animal must be supplied with its own RFID tag and a unique identification number. The temperature sensor has to be mounted in the proper position and it has to be ready to send a signal to the controller. The microcontroller converts the signal and depending on the temperature selects one of the 4 hoppers with the right type and amount of food. The procedure is repeated as many times as necessary. The hopper opens and starts pouring food into the feeder. A control scale located under the feeder controls the amount of food. When the fluid is filled, the hopper closes automatically. When an animal approaches the feeder, the meal per day sensor checks if it has reached the maximum per day limit, and if it's so, the animal does not receive a food. This is basically the core of the system. In conclusion, we could say that the combination of these components in an automatic feeding system will contribute correct daily ratio of free grazing animals. The system will make farmers' lives easier by giving them control and more flexibility in animal feeding time. This is also reducing the cost of daily food transport, and the feeding system will automatically give the necessary nutrients to the animal and help with the tracking. This work was partially supported by the Bulgarian Ministry of Education and Science under the National Research Program called Young Scientists and Postdoctoral Students, second part, and it's approved by National Science Program called Intelligent Animal Husbandry. Thank you for your attention. If you have any questions, I will be really happy to give you a right answer.
Okay, so it's a good work. So I want to ask the question, is this system built or is in the design phase?
This is still on the design stage, but we have a quite good approach to starting with the real execution of this early this spring, because we have some things to handle. Because
How
we're
will
not
you
ready to
ensure
yet.
the accuracy of the system?
One more time, please.
How will you ensure the accuracy from the system? At appropriate time, there should be a feeder providing the food, okay, that is required by the animal.
Oh, there's many questions we have to figure out, but after the real building, after creation of this, we will try to figure out how exactly to separate the animals on the time zones, and many questions are coming.
Okay. Yeah, thank you very much.
Thank you.
Yeah, we can go ahead.
Okay, sir. Moving to the next presentation. For the next presentation, I would like to call Asama Abdul Razak Al Kasi for the paper title Offline Signature Verification Based on Neural Network. Ma'am, you can proceed with your presentation.
Good morning.
Good morning, ma'am.
I welcome the organizer of this esteemed conference and all those attending. Title of my research is the offline signature verification based on neural networks. Personal authenticity is crucial. Therefore, the biometrics-based system has been developed to support some information security feature. Person signature an essential biometric trait of a human being, can be used to verify their identification. In this study, mechanism for automatically verifying signature has been suggested. The offline properties of handwritten signature are highlighted in this study, which aims to verify the authenticity of the handwritten signature, whether they are real or forged using computer-based machine learning technique. The main goal of the developing such system is to verify people through the validity of their signature. In this research, image of a group of signature numbering 70 images were used. Image processing steps were performed on them and their features were extracted using median filter. After that, the eigenvector and eigenvalue were calculated using the principal component analysis algorithm. Then the backpropagation neural network algorithm was applied for training and testing, where the performance reached to 6.8 for each 82 epoch, and the accuracy was 99.98%. The proposed system contains three main steps. The first step is image pre-processing and then feature extraction and classification. Principal component analysis is a technique for finding pattern in data and expressing it such that its similarities and differences are highlighted. Its objective is to explain the greatest amount of variation with the fewest number of a principal component. In this diagram, explain the principal component analysis steps. After data acquisition, compute the covariance matrix of the feature. After that, perform eigenvector and eigenvalue for the image, and select the element to create feature vector to obtain the uploaded data. Proposed verification system. After colored image acquisition, pre-processing image are performed. This step aims to make the image noise-free and includes 6 stages. This image is present the original image. After that, convert to a grayscale image, and then resize image to 520 by 520, and then convert to black background to isolate the signature from the background. This image presents the signature isolated from the background. And this image show the median, use the median filter. In this image, present the full and thin image. And in this image, using binarization. After that, feature extraction are used. Feature extraction by using gradient methods are used by dividing the image to 8 by 8 subblock to obtain more accuracy. After that, principal component analysis are performed there to obtain feature vector. This feature vector passed to the backpropagation algorithm for training and testing. This diagram explains the overall verification system. After signature acquisition, perform a pre-processing by 6 steps, that is, convert image to grayscale, resize image to grayscale, isolate the background, use the median filter for noise reduction, thinning the blank, binarization, convert image to binary. And after that, feature extraction using a gradient feature. Then principal component analysis are performed. The output is feature vector passed to the artificial neural network backpropagation algorithm are used for training and testing. Artificial neural network results. Backpropagation algorithms are used in this step. The internal structure of this work consists of two hidden layers of 20 nodes, and the output layer is used to classify the signature image type, where the quantity of training is 55 and the quantity of the image used for testing is 15. And the best training performance is 6.8 at 82 epochs. This figure showed the accuracy of the training process during 82 epochs. This table explain the real sample were used and trained. 70 image for total image and 55 used for training and 15 image for testing. Conclusion: the overall recognition rate is lower when 110 signatures are verified offline due to the high variability between users. Compared to cutting-edge work, the validation rate in this study was increased using the proposed methodology. The process in this method are as follows. A gradient filter was used to extract feature, improve contrast, and filter out image noise, normalize the signature length, segment the image to subblock 8 by 8 to obtain more accurate features, and finally, the classifier used backpropagation neural network database consists of 700 signature is used for evaluation. The accuracy attempt reached to 99.98%. Thank you for your attention.
It's a good presentation.
Thank you.
Sir, any questions? Sir, any questions? Sir is not having any questions. So let's move forward to the next presentation. And for the next presentation, I would like to call Ona Rotaro for the paper title, Switching from Doors to Doors, Next Generation, Identifying the Main Usability Issue, a Case Study. Ma'am, you can proceed with your presentation.
Hello, everyone again. Please let me know if you see my screen.
Yes, ma'am, it is visible to us.
Okay, thank you.
Go ahead, we can go ahead. Okay, thank you. Am I
Okay.
audible, Karthik, sir?
Yes, sir.
I am audible, right? No.
Yes, sir.
Okay, okay. So no problem. Thank you, thank you. We can go ahead.
Okay, so good morning again. My name is Ona Rotaro and I will present the paper entitled Switching from Doors to Doors Next Generation, Identifying the Main Usability Issues, a Case Study. In the beginning, I'll present some introduction aspects regarding the requirements engineering and requirements management tools. The requirements engineering has an important role in the automotive industry. And as long as this industry evolves, it leads to a complexity of systems and technologies, and the need for well-defined and accurate requirements gets higher. The requirements management is a part of the requirements engineering process and takes part in requirements engineering and management tools. These RM tools, requirements management tools, should support requirements acquisition, specification, review workflows, attribution, detailed level derivation, for instance, the derivation from customer level to system software, detailed design levels, test cases, linkages, status tracking, and also teamwork as collaborative work. These platforms are mainly used by engineers, developers, requirements engineers and managers, test engineers. Also, these tools are an environment for V model applicability. in software development, which links the development phases with corresponding testing phases. These two RM tools under the loop for the study are DOORS, IBM Rational DOORS, and DOORS Next Generation, tools that support elicitation, documentation, requirements analysis, traceability, and customization. Usability is another key aspect for our study. It measures how easily a product is used in order to accomplish specific goals in an efficient way. Some of the evaluation methods used in the study are the user testing session, the think aloud protocol, focus group. We also applied the system usability scale survey and the product reaction cards. The main focus of this paper is the comparative user experience analysis of IBM Rational DOORS and DOORS Next Generation, or DNG, motivated by the industry transition between these tools, transition visible in an automotive company. The outcomes of this study include finding usability challenges of both platforms, comparing system usability scale scores from the new users, also for both tools. The study aims to optimize use of DNG, possible target the training material for the new employees of the company, or serve as the foundation to develop usability evaluation criteria for RM tools. So the evaluated tools are DOORS and DOORS Next Generation, and the table presented here illustrates the demographic profile of the participants. The first method of the evaluation applied was the user testing session with a total of 10 participants with roles like students as interns, requirements engineers and managers, or quality engineers. For the evaluation of DOORS, we used novice users, new users, while for DOORS Next Generation, there were 10 participants. 5 of them new users, and 5 of them with some experience in a similar tool like DOORS. The participants were handed 9 tasks to be performed, same tasks for both platforms, and they were encouraged to think aloud. The focus group was applied on the experienced users when testing the DOORS NG tool, with the scope of comparing the platforms based on their immediate experience. The system usability scale survey and the product reaction cards methods were applied on all the users of the evaluation. We obtained 3 sets of results. The first set of results is for DOORS Next Generation with the mixed participants. The results are a product from the user testing session, the SUS survey, and the product reaction choices. The second set is also for DOORS NG with the participants experienced already in DOORS. Here we also obtained usability issues and some focus group insights. The third set of results is for both RM tools with the new users. The results are here are products from the user testing session, the survey, and the product reaction card choices. The first set of results include the results from all the participants, either beginners or having prior experience in a similar tool, and these results are regarding DOORS Next Generation, the new introduced tool. From the user testing session, 20% of the participants couldn't apply the given filters. All of them had navigation issues without a visible module explorer. 80% of them struggled with linking the test cases to some requirements due to the multiple link types offered by the tool. Although the participants valued some of the tool's features, like the multiple ways to add comments, attribute editing, informing some of the users on the changes. The average time taken per participant was 26 minutes, and the average task completion rate was 74.2%. The system usability scale was applied after the user testing session, and the score obtained was 68, graded as poor. This shows moderate usability with serious improvements needed. The participants were also asked to choose some cards reflecting on their immediate experience, and these here are their choices. The negative words are complex, confusing, difficult, stressful, but we also have positive ones like accessible, familiar, attractive. The second set of the evaluation results are also regarding DORS NG from the participants with already gained experience in the older tool, DORS. The focus group was applied for these participants, and the feedback regarding the user interface summarized like this. 40% of them found DORS NG more attractive than DORS. 60% felt that the interface is quite overwhelming due to many icons and sidebars, and all of them found the new streaming concept feature confusing, preferring the DORS simpler baseline concepts. They were also able to find some commonalities with DORS, like the commenting, the creation of filters or views. But a big concern from the focus group was related to the Module Explorer accessibility via an installable widget and not by being embedded in the view. 4 of the participants considered that knowing a similar tool can be helpful navigating in the new one, while only 1 participant considered this as being more confusing than helpful. The SUS score was 48, indicating serious challenges in usability, and the reaction cards chosen were complex, difficult, confusing, but also useful. And this may indicate some valid feature despite the usability issues. The third set of results reflects a comparison between the results for DORS, NG, and DORS after the new users evaluation. As we can see here, for DNG on the left side, 100% of the participants didn't find the Module Explorer for navigation. 80% had issues with the requirements linking. 60% faced issues making the edits visible to other participants. Meanwhile, for DORS, on the right side, 40% of the participants had difficulties with requirements linking to test cases. 20% also had issues adding or linking new requirements. There are some valued assets for DNG as the alternative scenarios for creating traceability and new artifacts, while in DORS, the Module Explorer was valued for document navigation. As the average task completion time, 16 minutes were taken for DNG, while 13 minutes for DORS. The system usability scales for the tools evaluation are quite comparable, 68 for DORS NG and 70 for DORS. The chosen cards for DNG are accessible, complex but rigid, while for DORS are all stable clear. In conclusion, DNG was more valued for the friendly user interface, and DORS was more appreciated for the stability and helpful user hints. On the left side, you can see the main view of the user testing session participants in DORS Next, and on the right side, you can see the corresponding view, but in DORS. In the conclusions, the aim of the study was a transition evaluation from DORS to DORS NG within an automotive company. There were 10 participants at the evaluation for the user testing session, people with various levels of experience, and we attained 3 sets of results. The main usability challenges found are focused around the filters application, documents navigation, artifacts linking in DORS NG, but also appreciated facts are the multiple actions that can be done via right-clicking. From the impact of prior experience point of view, we got mixed feedback from the participants, 4 of them considering it a benefit, while 1 participant finding it overwhelming, especially on the new streaming feature, which generated confusion for all the participants. The SUS scores are slightly different. DORS has a slightly higher score than DORS Next, suggesting a friendlier user interface for the new tool, but more stability for the older one. As a future research, we aim to explore other RM tools, focusing on features like traceability, collaboration, communication, reporting, and visualization, in order to identify common usability issues and improve tool design. Also, one future research topic would be investigating and proposing ideal user journeys for the accomplishment of basic tasks in RM tools, and in the end, to research the possibility to design adaptive user interface based on the role in the project. Thank you very much.
Basically, why there is a need to transit? What was the actual requirement?
That was an internal decision for this automotive company where I'm actually working at as a requirements manager. So that was an internal decision. Doors is an older tool. The management apparently considered it being a little
Review
old
from
and
10 participants seems to less actually for review purpose.
Sorry, can you repeat the question?
You said that there were 10 participants who gave the opinions, right?
Yes, for the new tool. Yeah.
Yes, but that is too less actually, 10 participants.
Yes, but we always can extend the the usability evaluation. We actually thought of this by the survey method. I think a survey to more participants would be really helpful in this direction, and we actually aim to do this.
So, thank you very much.
Thank you.
Thank you, ma'am and sir. Now we are moving to the next presentation. For the next presentation, I would like to call Krilke Kratsov for the paper title, Using the Decision Tree Model Method for Data Analysis. Sir, you can proceed with your presentation. I think the sir is facing some network issue. So let's move on to the next presentation. For the next presentation, I would like to call Jane Christine for the paper title Yield Prediction of Rice Using Random Forest Algorithm with Geographical Information System. Ma'am, you can proceed with your presentation.
All right, so good day. Okay, so were you able to see my screen?
Yes, ma'am, your screen is visible to us.
Visible.
Okay. Right. Okay, so good day. I am Miss Jane Kristen Suarez, and together with Dr. Jeneline V. Abamo. So I'm going to present the research entitled Yield Prediction of Rice Using Random Forest Algorithm. Now, for the outline of the topic, so I will be discussing the following, such as the introduction, the general objective, the conceptual framework, the methodology, description of the prototype, results and discussions, and lastly, conclusions and recommendations. Now, data mining, which is otherwise called as a data or knowledge discovery, is the method of evaluating and classifying data from previous prospect and encapsulate it into useful information. In the past, yield prediction was performed by considering farmers' experience on a particular field crop. And it is interesting to note that farmers nowadays harvest not only crops, but also growing amounts of data. So in this study, the researchers utilized the data mining, machine learning classification, and GIS-based model for visualization in the prediction of yield. A minimum of 5-year historical data will be used as a training data set and test data set for the yield status. And for visualization, a spatial map will be provided to indicate the location of high and low status of future yield. For the general objective of the study is to develop a framework in phase 1 and a yield prediction system in phase 2 that will serve as a basis for decision-making and implementation of policies, plans, and other projects of the target client, which is the Provincial Agriculture Office of Bulacan in the Philippines. For the specific objectives, Objective number 1 is to identify the different agricultural parameters that influence the rice yield in Bulacan, Philippines. The expected output in objective number 1 is the dataset, variable importance. And for objective number 2, to develop a framework for predicting the rice yield using the random forest algorithm. The expected output is the prediction model. The third objective is to evaluate the accuracy, reliability, and validity of the model in rice yield prediction. The expected output in objective number 3 is the results in validation, precision, recall, F-measure, the inter-rater reliability, confusion matrix, Cohen's-Kappa statistics. And lastly, to develop a yield prediction system using the most appropriate programming language. And the output of objective number 4 is the yield prediction of rice with GIS-based model for visualization. Now, for the framework, the researchers make use of the input process output. So we have for input the biotic, abiotic, agroclimatic parameters. And for the process, we have the data mining process, the software development, and lastly is the evaluation. And the output would be a functional system for yield prediction with GIS for visualization. Now, for the methodology, these are the steps involved in the predictive modeling phases employed by the researchers. So we get the data, we clean, prepare, and manipulate the data. We train the model, we test the data, and lastly is the prediction model. Now, in getting the data, we have requested the rice accomplishment report from the Provincial Agriculture Office of Bulacan. The data set ranges from year 2014 to 2021. So in this step, all possible attributes used in the data mining discovery task in order to determine the target set will be then identified. So this is the rice program accomplishment report. And then the next step would be to clean, prepare, and manipulate the data. So in this step, the researchers removed the outliers and we dealt with the missing values in the data. And then significant attributes was then determined in this step, and thus all irrelevant attributes from the original data set was removed. In training the model, the researchers identified the most suited data mining technique or algorithm that can provide the best prediction regarding the prediction of rice. So that is the crop. So we test the data. So the researchers came up with patterns discovered in databases, and we presented it in proper format that the data mining tool can be recognized. And lastly is the prediction. So we have conducted visualization of the data based on the extracted models, and then the extracted knowledge will be used and be incorporated into the development of the system. Now, let me share with you the description of the prototype. This is the prototype for the model. So we have the test data, the attributes, and then we have buttons such as the run prediction, plot, map, summary, and then the data. Okay, and then in this figure, we have selected here, we have loaded actually the test data, and then the period cover is from 2014 to 2021. We filtered it, we can filter it by municipality as shown in figure 3. And lastly, this would be the visualization. We can then identify or locate in the map in where particular, for example, municipality will be having, for example, a low and high yield based on the model. So for the results and discussion, for objective number 1, so we have the researchers identified the agricultural parameters by requesting the rice yield profile from the Provincial Agriculture Office of Bulacan. So in this section, so all possible attributes were gathered, the abiotic, agroclimatic, abiotic, and agroclimatic that we use in the data. So we collaborate with different offices such as the Philippine Rice Research Institute, the Regional Crop Protection Center, the Philippine Atmospheric, Geophysical, and Astronomical Services Administration, and the Bureau of Soil and Water Management. Now, this is in this figure, we have established together with the Department of Agriculture all of those biotic, abiotic, and agroclimatic parameters to be used in the study. And then here are the collaborators' profile. And then we have collected the accomplishment reports coming from District 1, District 2, District 3, and District 4. So the data ranges from 2014 to 2021 of Rice Accomplishment Report. It consists of the 6-year data with the following parameters. We have 5 biotic agricultural parameters such as soil, salinity, fertilizer, rice variety, insect pests and diseases, and we have 12 abiotic parameters, namely temperature, relative humidity, season, topography, irrigation, planting date, land area, production per area, the planting method, the rainfall, solar radiation, and wind velocity were selected based on the defined attributes used by also different researchers who conducted similar study. And it was then subjected to attribute evaluator. So we have considered the province of Bulacan with 12 municipality and 332 rows of data and 25 parameters. Now, we have performed attribute evaluation through WECA, so a data mining tool, into the set of possible attributes. So those attributes are 5 biotic, 12 abiotic, and then were selected based on the defined attributes used by different researchers also. Now, in objective number 2, we implement the rice yield prediction of rice using random forest algorithm with GIS in Bulacan, which aims to enhance the agricultural productivity of optimize resource management and support decision-making processes with the regional rice farming sector. So furthermore, the implementation provides agricultural researchers with valuable data for analysis, research, and the development of new farming techniques, crop varieties, and agronomic practices. So by studying the relationship between geographical factors, environmental conditions, and rice yield, the researchers can contribute to the advancement of agricultural science and promote sustainability. Now, here is the framework that have resulted in phase 1, which is the development of the framework. So the training set is used for building the model, and the testing set is to test the validity of the model. So in the data mining tool, so we have tested under 4 test options, namely the full training set, the supplied test set, and the cross-validation, and then percentage split. So the algorithm that is used to predict the yield as high or low got a computed kappa value of 0.7327, which is substantial enough to conclude that the algorithm use is reliable. So under the literature, it is indicated that the level of acceptable inter-rater reliability is being around a kappa value is greater than 0.6 or even kappa value is greater than 0.5. So out of the available data sets, around 322 instances were chosen, with 302 being classified as true positive and 18 as false negative. Only 18 instances were inaccurately classified. So the calculated degree of agreement between the generated prediction by the developed system and then the actual yield of rice from the report of the Provincial Agriculture Office was compared by the researchers in order to assess the system's accuracy and dependability in predicting the yield of rice. So we came up with a short list of numerous algorithms. We considered the following, such as the effect of weather, the climate variability in rice production, and rice yield prediction using satellite imagery and neural networks. So the rice prediction using the radar remote sensing and crop model and crop yield prediction using random forest was made after studying and testing the different approaches such as the bias classifiers, decision tree, random forest, and the role classifier. So as indicated, we have tested it under 4 test options. So the dataset was separated into 2 distinct subsets, so the training and the testing, so which comprises of 70% training and 30% testing, respectively. So the purpose of the training set is to construct the model, while the testing set is intended to evaluate the validity of the model. So we use the training set. There are 275 instances predicted as true positive and 16 as false negative, which means that there is a total of 275. So out of 322, which is approximately 70% of total data sets, so instances correctly, thus yielding an overall percentage of 94 correct classification. So on the other hand, when the model build was tested using the testing data set, it was found that 97 instances out of 322 were classified correctly. So giving an overall percentage of 30% correct classification. Out of the available data sets, around 322 instances were chosen
Hello,
with
madam.
300. Yes, po. Yes, yes, sir.
So what makes you to select this random forest algorithm compared to other approaches?
All right. So based on the evaluation, we have here tested.
What
So
type of evaluation?
among the 4 test options, so random forest using the cross validation has, well, we know second highest, but random forests were chosen, although it ranked second compared with JRIP and J48 because of the time that built the model. So the shorter period should be given more weight, and it is random forest.
Okay, thank you.
All right. So that ends my presentation, and thank you very much for listening.
Thank you, ma'am.
Thank
Sir,
you.
any further questions?
No, thank you.
Thank you. All right.
So here we are moving towards the closing remark.
Um, From
I
my
sincerely
side,
thank our authors for their
Okay.
excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this conference was informative enough. We, on behalf of the whole team, thank you for your support during the 9th version and all the previous 8th version of the conference. We'll be happy to have you in the 10th version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2024. I also thank our session chair, Dr. Amar, for chairing the session. This is the token of appreciation on behalf of the team, ICICT 2024 and Global Knowledge Research Foundation and partners. Sir, kindly acknowledge our participants.
Yes, thank you for appreciation. Thank you very much.
Thank you, sir. Now I would love to extend my gratitude to the next session chair, Professor Emmanuel, for chairing the session.
Karthik sir, should I leave?
Just a second, we are waiting for a quick snapshot, then you may.
Okay.
Thank you, sir.
No problem.
This is a token of appreciation to the chair on behalf of Team ICICT 2024 and Global Knowledge Research Foundation and partners. Emmanuel, sir, kindly acknowledge our participants. I think the sir is facing some network issues. It's okay. So we are moving toward the end of the session. I request you all to turn on your cameras for a quick virtual snapshot. Thank you, everyone. Thank you, everyone.
Thank you very much.
Stay safe, stay connected.
Thank you.
Take care.
Thank
Yes,
you.
thank you very much for giving
Thank you, ma'am.
opportunity.
Thank you, sir.
Thank
sir.
you, thank you,
Thank you, ma'am.
thank you.
Thank you.